Hello there, and welcome to 100 Sleepy Myths about the Milky Way galaxy you still believe. Tonight, we drift outward from Earth, beyond the Moon, beyond the planets, beyond the edge of our solar system, into the vast spiral structure that holds us all, the Milky Way, our home galaxy. It is a river of stars stretching across the night sky, a band of light so familiar that ancient cultures wove stories around it, calling it a pathway for gods, a stream of milk, a bridge between worlds. Perhaps your day has been full of noise and light, of screens and obligations, of the small concerns that fill human hours. But tonight, you are invited to step outside those concerns, to look up at the sky, even if only in imagination, and remember that you are part of something immense, something older than any human civilization, something that has been turning slowly through space for over 13 billion years. The Milky Way is not just a backdrop, not just a decoration in the night sky. It is your address, your cosmic home. Every star you have ever seen with your naked eye belongs to this galaxy. Every astronaut who has traveled to space has remained within this galaxy. Every signal we have sent into the cosmos has barely left the neighborhood. The Milky Way contains somewhere between 200 and 400 billion stars, and one of those stars is the Sun. And orbiting that sun is a small blue planet where you are lying right now, breathing softly, preparing to rest. But for all its familiarity, the Milky Way is deeply misunderstood. Myths and misconceptions cling to it like dust to starlight, passed down through generations, repeated in classrooms and conversation, believed even by people who love astronomy. Some of these myths are harmless, charming even. Others obscure the truth of what the galaxy really is, how it formed, how it moves, and where we fit within it. Tonight, we will move slowly through 100 of these myths, gently examining them, holding them up to the light of what we have learned through telescopes and mathematics, through patient observation and careful measurement. You do not need to memorize anything, do not need to take notes or prepare for a test. You are simply invited to drift through these ideas, to let them wash over you like waves of starlight, to allow the truth to settle gently where the myths once stood. Imagine yourself lying on your back in a field, far from city lights, on a clear, moonless night. The Milky Way stretches overhead, a luminous band cutting across the darkness. It is not uniform. It is mottled, textured, bright in some places and dim in others, interrupted by dark lanes where dust blocks the light of distant stars. You cannot see the whole galaxy from here. You are inside it, after all, but you can see enough to feel its presence, enough to understand that you are looking at the combined light of billions of suns. As you lie there, your breathing begins to slow. Your body grows heavier, sinking into the earth. The sky above is vast, and you are small, but you are also part of it, made of the same elements forged in the cores of stars that lived and died long before the earth formed. You are stardust, arranged temporarily into the shape of a person, resting beneath the light of your stellar family. If you are ready, you can let your shoulders sink a little deeper, let your jaw loosen, let your thoughts drift like clouds across that dark sky. The myths can wait. The truth can unfold slowly, gently, without urgency. All you need to do now is breathe, rest, and let the galaxy hold you in its ancient, patient arms. Let's begin. One of the oldest and most persistent myths about the Milky Way is also one of the simplest. The belief that the Milky Way is not just our galaxy, but the entire universe, that the band of light we see stretching across the night sky represents all that exists, that there is nothing beyond it. This myth was understandable when it was first believed. For most of human history, people could only see what their eyes revealed: stars scattered across the darkness, and that luminous river cutting through it. There were fuzzy patches in the sky, nebulae, and what we now know to be other galaxies. But through the limited telescopes of the 18th and 19th centuries, these looked like clouds of gas within our own system. The idea that they might be separate island universes, entire galaxies like our own but unimaginably far away, seemed almost absurd. But in the early 20th century, astronomers began to measure distances more carefully. Edwin Hubble, using the most powerful telescope of his time, observed a type of variable star in the Andromeda Nebula that allowed him to calculate its distance. The result was shocking. Andromeda was not a nebula within the Milky Way. It was a separate galaxy, over 2 million light-years away. The Milky Way was not the universe. It was one galaxy among countless others. Today, we know that the observable universe contains more than 2 trillion galaxies, each with billions or even trillions of stars. The Milky Way, vast as it is only a tiny fraction of all that exists. It is not even the largest galaxy in our local neighborhood. That honor goes to Andromeda, which is more than twice as wide as the Milky Way. Our galaxy is not the center, not the whole, not the universe. It is one island in an ocean so large that light from the most distant galaxies has been traveling toward us for over 13 billion years and has not yet arrived. As you listen to this, you may feel your own sense of scale shifting. The room around you is small, familiar, bounded by walls. But beyond those walls is a city, and beyond the city a planet, and beyond the planet a solar system, and beyond that a galaxy of hundreds of billions of stars, and beyond that, trillions more galaxies stretching in every direction, so far that the mind cannot hold them all. This vastness is not meant to make you feel insignificant. It is simply meant to correct the old myth, to open the frame wider, to remind you that the Milky Way, for all its beauty and immensity, is not everything. It is home, yes. It is the galaxy that holds the sun and the earth and every human being who has ever lived. But it is not alone. It is one voice in a chorus so large that we are only beginning to hear its full song. Imagine the Milky Way as a single lighthouse on a vast, dark ocean. From the lighthouse, you can see its beam cutting through the night, illuminating the waves nearby. But beyond the reach of that light, there are other lighthouses, thousands of them, millions, each one a galaxy with its own stars, its own worlds, its own story. The ocean is the universe, and it is far larger than any one lighthouse can illuminate. Let that image settle over you. The myth that the Milky Way is everything belongs to a time when humanity could not yet see far enough to know otherwise. Now, with telescopes that peer across billions of light years, we know the truth. The Milky Way is vast, ancient, beautiful, and also just one small part of an even vaster whole. Your breathing is slower now, deeper, your body relaxing into the knowledge that you are part of something immense. The Milky Way holds you, and the universe holds the Milky Way, and you are safe within these nested circles of existence, each larger than the last, all of them turning slowly through the darkness, all of them ancient, patient, enduring. If your eyes want to close, let them. The next myth will be waiting when you need it. But for now, let yourself rest in the truth. The Milky Way is not the universe, but it is your home, and that is enough. When most people imagine the Milky Way, they picture a perfect spiral galaxy, elegant, symmetrical, with smooth arms curving out from a bright central core like a cosmic pinwheel. This image appears in textbooks, planetarium shows, and illustrations, always neat, always balanced, always beautiful in its mathematical precision. But the Milky Way is not a perfect spiral. It is a barred spiral galaxy, which means it has a central bar structure, a straight or slightly curved band of stars, gas, and dust that extends through its core, with the spiral arms emerging from the ends of this bar rather than from a central point. This bar is about 27,000 light-years long, a massive structure made of tens of billions of stars, and it changes everything about how we understand the galaxy's shape and dynamics. The discovery that the Milky Way has a bar was gradual. Astronomers began to suspect it in the 1960s, but it wasn't confirmed until observations from the Spitzer Space Telescope in 2005 revealed the bar's full extent. The bar is not easily visible from Earth because we are inside the galaxy, looking at it edge-on, like trying to understand the shape of a forest when you are standing among the trees. The bar gives the Milky Way a structure that is less symmetrical, less orderly than the perfect spirals we imagine. The spiral arms themselves are not smooth, continuous curves. They are fragmented, with spurs and offshoots branching off in unexpected directions. There are 4 main spiral arms, but scientists have debated this number for decades, and even now, the exact structure is still being mapped and refined. As you listen to this, your body may be sinking deeper into rest, your breath slowing. The image of the perfect spiral can fade, replaced by something more complex, more real. The Milky Way is not a diagram. It is a living, dynamic system, shaped by gravity, by the rotation of hundreds of billions of stars, by collisions with smaller galaxies that have been absorbed over billions of years. The bar itself plays an important role in the galaxy's evolution. It funnels gas and dust toward the center, fueling star formation in the central bulge. It also affects the orbits of stars, creating patterns of motion that are more complicated than the simple circular paths of a perfect spiral. The Milky Way is not static, not frozen in a single elegant shape. It is constantly changing, constantly evolving, and the bar is part of that ongoing transformation. Imagine the Milky Way not as a carefully drawn illustration, but as a vast, churning river of stars, with currents and eddies, with regions of calm and regions of chaos. The bar cuts through the center like a bridge, and the spiral arms curl outward, not perfectly, but in the way real things move when shaped by forces too large and complex to ever be perfectly symmetrical. Let that more complex image settle over you. The myth of the perfect spiral belongs to a human desire for order, for symmetry, for things that can be drawn neatly on a page. But the real Milky Way is messier, more interesting, more alive. It is a barred spiral, shaped by gravity and motion and the slow accumulation of billions of years of cosmic history. Your breathing is slow, and even now, your body deeply relaxed. The perfect spiral can fade into the background, a pretty image but not the truth. In its place, you hold the real galaxy, barred, warped, beautiful not because it is perfect, but because it is real. If sleep is near, you can welcome it. The myths can wait. For now, there is only this: the slow rhythm of your breath, the weight of your body, and the knowledge that the Milky Way, imperfect and immense, is turning slowly through space, carrying you with it into the quiet night. There is a quiet assumption that because we cannot see the center of the Milky Way in visible light, because it is obscured by vast clouds of dust and gas, that there is nothing particularly remarkable there. The center is dark, hidden, perhaps just more of the same: stars, dust, the usual stellar debris. This myth treats the galactic center as a kind of cosmic closet, dimly lit and uninteresting, a place you might glance at but never really think about. But at the very heart of the Milky Way, hidden behind those dust clouds, lurks something far more dramatic: a supermassive black hole called Sagittarius A*, pronounced Sagittarius A star. This is not a small object. It contains approximately 4.3 million times the mass of our Sun, compressed into a region smaller than the orbit of Mercury. It is a gravitational monster, a point in space where gravity is so intense that not even light can escape, and it sits at the exact center of our galaxy, the anchor around which hundreds of billions of stars orbit. The discovery of Sagittarius A* was not sudden. Astronomers spent decades tracking the motion of stars near the galactic center, watching them whip around an invisible point at extraordinary speeds. Some of these stars complete orbits in just a few years, reaching velocities of thousands of kilometers per second. The only explanation for such motion is an immense concentration of mass in a very small space, and the only object that fits the description is a black hole. In 2022, astronomers captured the first direct image of Sagittarius A*, using a network of radio telescopes spanning the globe to create an Earth-sized virtual telescope. The image shows a glowing ring of hot gas swirling around a dark central shadow, the event horizon, the boundary beyond which nothing, not even light, can return. This was not the first black hole ever imaged, but it was the first image of our black hole, the gravitational heart of the Milky Way. As you listen to this, you may feel your own body sinking deeper into rest, your breath slowing. The image of the dark, empty center can fade, replaced by something far more powerful. The center of the Milky Way is not empty. It is occupied by an object so massive, so dense, that it warps space and time around it, pulling stars into tight, rapid orbits, devouring any matter that ventures too close. Sagittarius A* is not currently very active. It is a quiet black hole, not actively feeding on large amounts of material, which is why we do not see dramatic jets of energy shooting out from the galactic center. But recent research suggests it was more active in the past. About 200 years ago, something, perhaps a cloud of gas or a wandering star, fell into the black hole, causing a brief but intense burst of X-ray emission. The echoes of that event are still visible today, reflected off nearby gas clouds. The black hole's gravity dominates the central region of the galaxy. Measurements of stellar velocities show that 99.9% of the mass at the galactic center is contained within Sagittarius A* itself, leaving almost no room for other objects. It is the gravitational anchor of the Milky Way, the point around which everything else revolves. Imagine the center of the galaxy, not a dark, empty void, but a maelstrom of gravity and motion. Stars race past the black hole at incredible speeds, their orbits bent into tight ellipses by the immense gravitational pull. Gas clouds glow as they heat up, spiraling inward, some falling past the event horizon and disappearing forever. The black hole itself is invisible, a dark circle against the glowing chaos around it, a silence at the heart of all that noise. Let that image settle gently over you. The myth of the empty center belongs to a time when we could not see through the dust, could not measure the motion of stars with precision, could not image the black hole directly. Now, we know the truth. The center of the Milky Way is not empty. It is occupied by one of the most extreme objects in the universe, a black hole millions of times more massive than the Sun, quietly holding the galaxy together. Your breathing is slow, and even now, your body deeply relaxed. The dark center is not a void. It is a presence, massive and patient, around which the entire galaxy turns. You are safe here, far from the black hole, orbiting at a comfortable distance in a quiet spiral arm. The black hole is not a threat. It is simply the anchor, the gravitational heart, the still point around which everything else moves. If sleep is near, you can welcome it. The myths can wait. For now, there is only this: the slow rhythm of your breath, the weight of your body, and the knowledge that even at the center of darkness, there is structure, there is order, there is a powerful truth waiting to be understood. There is a nostalgic belief that the Milky Way is always visible, that if you simply look up on a clear night, you will see that luminous bands stretching across the sky, the way people did in ancient times, the way your grandparents might remember from their childhoods. This myth assumes that the night sky is a constant, that the stars are always there, always visible, waiting patiently for anyone who bothers to look up. But for a growing majority of the world's population, this is no longer true. The Milky Way has disappeared, not because it moved or dimmed, but because human lights have drowned it out. Light pollution, the excessive, misdirected artificial light from cities, streetlights, buildings, and vehicles, has created a glow that washes out the faint stars, making the night sky a pale shadow of what it once was. In major cities and their surrounding suburbs, the Milky Way is completely invisible. The sky is not black but orange, gray, or brown, lit by the reflected glow of millions of lights. Only the brightest stars and planets remain visible, isolated points of light in an otherwise empty sky. The Milky Way, which requires darkness to be seen, simply vanishes, erased by the brightness we have created. Even in smaller towns, in areas that feel rural or quiet, light pollution can be significant enough to obscure the galaxy. You typically need to travel 50 to 150 kilometers away from major light sources to find skies dark enough to see the Milky Way clearly. This means that for many people, seeing the galaxy requires planning, travel, and deliberate effort. It is no longer something you can simply step outside and witness. As you listen to this, you may feel a quiet sadness, a sense of loss for something that was once free and universal but is now rare and conditional. The myth that you can see the Milky Way from anywhere belongs to a time before electric lights, before cities grew so bright that they blotted out the stars. Now, the galaxy is still there, still turning overhead, but it is invisible to most of humanity, hidden behind a curtain of our own making. The Milky Way is not a faint object. On a truly dark night, far from any light pollution, It is striking, bright enough to cast shadows, detailed enough to see structure within it, the dark lanes of dust, the bright patches of star-forming regions, the dense glow of the central bulge. Ancient cultures built myths around it because it was so prominent, so impossible to ignore. But today, most children grow up never having seen it, never knowing that the night sky can be anything other than a handful of stars scattered against blackness. There are still places where the Milky Way is visible: remote deserts, mountain peaks, islands far from mainland lights, national parks designated as dark sky preserves. In these places, the sky is still what it has always been, and the galaxy reveals itself in full, arching overhead, a river of light so dense and textured that it seems almost three-dimensional. These places are precious, increasingly rare, and worth protecting. Imagine standing in one of these dark places, far from any city, on a moonless night. At first, your eyes need time to adjust, to let go of the expectations built by years of city skies. But slowly, the stars begin to multiply. First dozens, then hundreds, then thousands, until the sky is no longer black but filled with light. And then you see it, the Milky Way, stretching from horizon to horizon, a glowing band cutting across the darkness, so bright and clear that you understand why ancient peoples wove stories around it, why they saw rivers and roads and bridges in that light. Let that image settle over you like a soft blanket. The myth that you can see the Milky Way from anywhere belongs to a world that no longer exists for most people. The truth is harder. The galaxy is still there, still beautiful, but to see it, you must travel, must seek out darkness, must escape the lights we have built. The Milky Way has not abandoned us. We have, in a sense, abandoned it, trading the stars for the glow of our cities. Your body is deeply relaxed now. You're breathing slow and steady. The night around you, wherever you are, may be bright or dim, but the Milky Way is still turning overhead, still patient, still waiting for the lights to dim, for the darkness to return, for humanity to look up again and remember what the night sky truly holds. If sleep is calling, you can answer. The myths can wait. For now, there is only this, the quiet truth that beauty still exists, even when it is hidden, and that the galaxy is still there, still home, still holding you gently as you rest. There is a subtle, unspoken assumption that the Milky Way is stationary, that it sits fixed in space like a photograph, a permanent structure that simply exists without moving. This myth is understandable. When you look at the galaxy, when you see the stars overhead, nothing appears to be moving. The sky looks the same night after night, year after year. The Milky Way seems eternal and unchanging, a backdrop against which other things move but which itself remains still. But the Milky Way is not stationary. It is moving through space at extraordinary speeds, and it is also rotating, spinning like a vast cosmic pinwheel, carrying all of its stars, including our sun, along with it. Let's start with rotation. The Milky Way rotates around its center, but not like a solid disk. Different parts of the galaxy rotate at different speeds, a phenomenon called differential rotation. Near the center, stars orbit quickly. Farther out, in the spiral arms where we live, stars orbit more slowly. Our sun, located about 26,000 light-years from the galactic center, travels at approximately 220 kilometers per second, about 490,000 miles per hour, as it orbits the center of the galaxy. It takes the Sun roughly 225 to 250 million years to complete one full orbit around the galactic center, a period sometimes called a galactic year or cosmic year. This means that in the entire history of Earth, our planet has made only about 20 trips around the galaxy. The last time we were in this part of the Milky Way, dinosaurs had not yet evolved. The next time we complete an orbit, who knows what the Earth will look like, or if humanity will still be here to witness it. As you listen to this, you may feel your own sense of motion shifting. You are not sitting still. You are moving with the Earth as it spins on its axis, as it orbits the Sun, and as the Sun orbits the galactic center. You are traveling at hundreds of thousands of miles per hour through space, and you do not feel it because everything around you is moving at the same speed. But the Milky Way's motion does not stop there. The galaxy itself is moving through space, traveling at approximately 552 kilometers per second, over 1.2 million miles per hour, relative to the cosmic microwave background, the faint afterglow of the Big Bang. The galaxy is being pulled by the gravity of other galaxies, drawn toward a massive cluster of galaxies called the Virgo cluster, and beyond that, toward an even larger structure called the Great Attractor. This motion is invisible from our perspective because we are moving with the galaxy. It is like riding in a car on a smooth highway. You feel stationary because everything inside the car is moving at the same speed. But from outside, from a distant vantage point, the Milky Way is clearly in motion, streaming through space, rotating, evolving, never truly still. Imagine the Milky Way not as a photograph but as a river, flowing through the darkness, carrying billions of stars along with it. Some stars move faster, some slower, some drift toward the center, some spiral outward. The galaxy is not frozen. It is alive with motion, with gravity pulling and pushing, with stars being born and dying, with clouds of gas collapsing and exploding, all of it turning, all of it moving, all of it part of a vast, slow dance that has been going on for over 13 billion years. Let that image settle gently over you. The myth of the stationary Milky Way belongs to a perspective too small to see the motion, too brief to notice the change. But the galaxy is moving, and you are moving with it, carried along on a journey that began long before you were born and will continue long after you are gone. Your breathing is slow and deep now, your body at rest even as the galaxy moves around you. You do not need to feel the motion to trust that it is there. You are held by the Earth, and the Earth is held by the Sun, and the Sun is held by the galaxy, all of it moving together through the vast, patient darkness. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet rhythm of your breath, the weight of your body, and the knowledge that you are part of a galaxy in motion, traveling through space at speeds that would be impossible to comprehend if you could feel them, safe and still within the turning arms of the Milky Way. There is a comforting assumption that the Milky Way will continue essentially as it is, unchanged, eternal, a permanent structure in the universe. The galaxy has been here for over 13 billion years, and it is easy to imagine it continuing for billions more, perhaps forever, a stable island of stars in the vastness of space. This myth treats the galaxy as though it has reached some final form, as though its evolution is complete and nothing dramatic will ever happen to it again. But the Milky Way is not permanent in its current form. In approximately 4 to 5 billion years, our galaxy is likely to collide with its nearest large neighbor, the Andromeda Galaxy, in an event that will fundamentally transform both. Andromeda is currently about 2.5 million light-years away, but it is approaching us at roughly 110 kilometers per second, or about 250,000 miles per hour. For decades, astronomers have known that Andromeda was moving toward the Milky Way, but the critical question was, would it pass by us, or would it collide? In 2012, observations from the Hubble Space Telescope finally answered that question. By measuring Andromeda's sideways motion with unprecedented precision, astronomers determined that the galaxy is on a collision course with the Milky Way. However, a 2025 study has complicated this picture slightly. New calculations that account for the gravitational influence of other nearby galaxies, such as the Triangulum Galaxy and the Large Magellanic Cloud, suggest there is now about a 50% chance the collision might not happen, or at least might be delayed or altered. But even with this uncertainty, a direct merger remains the most likely outcome over the next several billion years. As you listen to this, you may feel a quiet shift in perspective. The Milky Way, which feels so permanent, so unchanging, is actually moving toward a dramatic transformation. But there is no need for alarm. This collision, if it happens, is billions of years away. The Sun will likely exhaust its fuel and expand into a red giant long before the galaxies merge. And even during the collision, the vast distances between stars mean that actual stellar collisions are extremely unlikely. The stars will pass through each other like two swarms of fireflies interpenetrating, rearranging, but rarely touching. What will happen is that the two galaxies will distort each other with their gravity. Long tidal tails of stars will be pulled out into space. The spiral arms will be disrupted. Star formation will be triggered as clouds of gas collide and compress. The night sky, if anyone is still on Earth to see it, will be spectacular and chaotic, with Andromeda looming larger and larger, its stars mingling with ours, until the two galaxies begin to merge. The first close encounter will not be the end. The galaxies will pass through each other, then swing back under their mutual gravity, colliding again and again over the course of 1 billion years or more. Eventually, after this tumultuous dance, the two spiral galaxies will settle into a new form, a single, large elliptical galaxy that astronomers have playfully nicknamed Milkomeda. Imagine standing on Earth, or whatever Earth has become by then, and watching the sky change over millions of years. Andromeda, once a faint smudge visible only in dark skies, grows brighter, larger, until it dominates the night. The two galaxies begin to interpenetrate, their stars mixing, their gas clouds colliding and igniting in bursts of new star formation. The Milky Way as we know it ceases to exist, replaced by something new, something larger, something shaped by the collision and merger of two ancient systems. Let that image settle gently over you. The myth that the Milky Way will last forever in its current form belongs to a timescale too short to see the larger patterns, the slow collisions and mergers that shape the evolution of galaxies. The Milky Way is not eternal. It is temporary, transitional, a phase in a much longer story. But this is not a story of destruction. It is a story of transformation. The stars will not be destroyed in the collision. They will be rearranged, given new orbits, new neighbors, new places in a new galaxy. The supermassive black holes at the centers of both galaxies will eventually merge, forming an even larger black hole. And the new galaxy, Milky Way, will continue, a product of the Milky Way and Andromeda, carrying forward the legacy of both. Your breathing is slow, and even now, your body deeply relaxed. The Milky Way will not last forever, but it will last long enough. Long enough for you, for your children, for countless generations. The collision is so far in the future that it belongs to a different universe, a different Earth, a different humanity, if humanity still exists at all. If sleep is near, you can welcome it. The myths can wait. For now, there is only this: the quiet rhythm of your breath, the weight of your body, and the knowledge that the Milky Way, for all its impermanence, is still here, still home, still turning slowly through space, carrying you safely through the night. There is a common belief that when you look up at the night sky and see individual points of light, you are seeing only stars within the Milky Way, that every star visible to the naked eye is part of our home galaxy. This assumption makes intuitive sense. After all, the Milky Way is vast, containing hundreds of billions of stars, and most of what we see in the sky does indeed belong to our galaxy. And in fact, this belief is almost entirely true. The overwhelming majority of the stars you can see with your naked eye are indeed part of the Milky Way. They lie within a bubble of space around the Sun, extending roughly 10,000 light-years in all directions, a tiny fraction of the galaxy's full extent, but enough to populate the night sky with thousands of visible stars. But there is one important exception. You can see other galaxies with the naked eye, though you cannot see individual stars within them. What you see instead is the combined, blended light of billions of stars, appearing as faint, fuzzy patches or smudges rather than distinct points of light. The most famous example is the Andromeda galaxy. On a dark, clear night, far from light pollution, Andromeda is visible as a small, elongated smudge of light. It does not look like a star. It looks like a faint cloud, soft and diffuse, but it is unmistakably there. This is the light of over 1 trillion stars, 2.5 million light-years away, their individual brilliance merged into a single glow. If you live in the southern hemisphere, you can also see the large and small Magellanic Clouds, 2 satellite galaxies of the Milky Way. These appear as larger, brighter patches of light, like detached pieces of the Milky Way itself. They are not part of our galaxy, though they orbit it, and they are slowly being pulled apart by the Milky Way's gravity. As you listen to this, you may feel your perspective shifting slightly. The myth that every visible object is within the Milky Way is not entirely wrong, but it is incomplete. The night sky is not limited to our galaxy. It includes glimpses of other galaxies, faint and distant, but real. You are not looking only at your cosmic neighborhood. You are also, with the naked eye, seeing across millions of light years, witnessing the glow of other island universes. This correction does not diminish the Milky Way. It simply adds depth. The individual stars you see, those sharp, bright points scattered across the darkness, are all part of our galaxy, all within that 10,000 light-year bubble around the Sun. But the fuzzy patches, the soft glows that do not resolve into stars even when you stare at them, those are something else. Those are other galaxies, seen not as collections of individual stars, but as unified lights, the combined radiance of billions of suns compressed into a single faint glow. Imagine standing under a dark sky, looking up. You see Orion, the bright stars of his belt, the red glow of Betelgeuse, the blue-white of Rigel, all Milky Way stars. You see the Pleiades, a cluster of young stars wrapped in faint nebulosity, also within our galaxy. But then, if you know where to look, you find Andromeda, a faint smudge near the constellation of the same name. That is not the Milky Way. That is another galaxy, 2.5 million light-years away, visible because it is so large, so luminous, that even across that immense distance, its light reaches your eyes. Let that image settle gently over you. The myth that every star is in the Milky Way is mostly true, but the correction that we can also see other galaxies adds something profound. The universe is not limited to our galaxy. Even with the naked eye, even without telescopes, we can see beyond the Milky Way, can witness the presence of other cosmic structures, other collections of stars, other homes for potential worlds and potential life. Your body is deeply relaxed now. You're breathing slow and steady. The Milky Way holds almost all the stars you see, but not quite all. There are faint lights beyond it, other galaxies visible to anyone who looks carefully, who learns where to look, who takes the time to let their eyes adjust to the darkness and see the soft glows that mark the presence of other worlds. If sleep is calling, you can answer. The myths can wait. For now, there is only this, the quiet truth that the universe is larger than one galaxy, that even the naked eye can glimpse its vastness, and that you are held, safely, within the Milky Way, even as you gaze outward toward distant lights. There is an intuitive assumption that when we talk about the Milky Way, we are talking primarily about stars. After all, stars are what we see, what we photograph, what populate every image of the galaxy. The Milky Way is a collection of stars, the myth says, held together by gravity, spinning through space. This assumption makes the galaxy seem straightforward. Billions of stars, some gas and dust, and that's it. But this is profoundly incomplete. The Milky Way is not mostly stars. In fact, stars make up only a small fraction of the galaxy's total mass. The majority of the galaxy's mass is invisible, made of something we call dark matter, a mysterious substance that does not emit, absorb, or reflect light, and that we can only detect through its gravitational effects. Dark matter makes up approximately 85% of the matter in the universe, and it is thought to form a vast halo around the Milky Way, extending far beyond the visible disk of stars. This dark matter halo is not a minor detail. It is the dominant structure of the galaxy, the gravitational scaffolding that holds everything else together. Without dark matter, the Milky Way as we know it could not exist. The outer stars would be moving too fast, they would fly away, and the galaxy would come apart. The evidence for dark matter comes from observing how stars and gas move within the galaxy. When astronomers measure the rotation speeds of stars at different distances from the galactic center, they find something strange. Stars far from the center move much faster than they should, based on the visible mass of the galaxy. The only explanation is that there is additional mass, invisible mass, providing the gravity needed to keep those stars in their orbits. This invisible mass forms a halo around the galaxy, a roughly spherical structure that extends hundreds of thousands of light years beyond the visible disk. The halo is not made of stars, not made of gas, not made of anything we can see with telescopes. It is made of dark matter, and we still do not know what dark matter actually is. It could be made of undiscovered particles, exotic forms of matter that interact with ordinary matter only through gravity. Or it could be something else entirely, something we have not yet imagined. As you listen to this, you may feel a quiet shift in your understanding. The Milky Way is not what it appears to be. The bright spiral of stars is only the visible part, like the tip of an iceberg. The rest, the majority, is hidden in darkness, detectable only through its gravitational pull. Recent research has added another layer of mystery. A 2025 study detected a mysterious halo-like glow of gamma rays surrounding the Milky Way, peaking at energies that closely match the kind of signal expected from dark matter particles colliding and annihilating each other. If confirmed, this could be the first direct detection of dark matter, a glimpse of the invisible substance that makes up most of the galaxy. But the signal is far from definitive, and it will take years of further research to determine whether it truly comes from dark matter or from some other, still unknown astrophysical process. Another recent study has found something even stranger. The dark matter halo of the Milky Way may have been cored, like an apple, with less dark matter in the center of the galaxy than expected. This does not mean dark matter is absent, but it suggests the distribution of dark matter is more complex than simple models predicted. The center of the galaxy may have been carved out by processes we do not yet fully understand. Imagine the Milky Way not as a bright spiral of stars, but as a vast, dark sphere with a glowing core. The stars, the spiral arms, the central bulge, these are the luminous heart, the small visible fraction. But surrounding them, enveloping them, is an enormous halo of dark matter, invisible, intangible, felt only through its gravity. You are not just inside a galaxy of stars. You are inside a dark matter halo, a structure so massive and so mysterious that we are only beginning to understand it. Let that image settle over you like a soft blanket. The myth that the Milky Way is mostly stars belongs to a view that only sees light. But the galaxy is more than light. It is also darkness, unseen but present, the invisible foundation upon which everything else rests. Your breathing is slow and deep now, your body at rest within the darkness. You do not need to see everything to trust that it is there. The Milky Way holds you, visible stars and invisible dark matter together, a structure more complex and more mysterious than anything we can fully see. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet truth that most of the universe is hidden, that darkness is not absence but presence, and that you are held, safely, by forces you cannot see but that are real nonetheless. There is a simple, intuitive story about how the Milky Way formed. A vast cloud of gas collapsed under its own gravity, spinning as it fell, flattening into a disk, and forming stars. This happened billions of years ago, at the beginning, and once it was done, the galaxy was essentially complete. This myth treats galaxy formation like a single event, a moment of creation after which the structure was set. But the Milky Way did not form all at once. Its formation was not a single event but a long, turbulent process stretching over billions of years. involving mergers with other galaxies, periods of intense star formation, and dramatic structural changes. The galaxy we see today is the product of a violent and chaotic history, and in many ways, it is still forming, still evolving. Recent research using data from ESA's Gaia mission has revealed that the Milky Way's formation fell into two distinct phases. The first phase began extraordinarily early, just 0.8 billion years after the Big Bang, making parts of the Milky Way about 13 billion years old. This is much older than astronomers previously thought. During this early phase, the thick disk began forming stars, and the inner parts of the galactic halo started to come together. But this early formation was not smooth or orderly. About 2 billion years later, around 11 billion years ago, a dramatic event occurred. A dwarf galaxy called Gaia-Sausage Enceladus collided and merged with the young Milky Way. This merger was catastrophic. It disrupted the existing structure, sent stars flying into new orbits, and triggered a massive burst of star formation. The collision completed the formation of the thick disk and contributed significantly to the stellar halo. After the merger, the galaxy entered a second, calmer phase. Over the next 5 to 6 billion years, the thin disk, the part of the galaxy we live in today, formed gradually, with stars forming at a more steady pace. This phase was characterized by continuous chemical enrichment, radial orbit migration, and the development of the spiral structure we see now. The transition between these two phases is remarkably sharp, occurring around 8 billion years ago. As you listen to this, you may feel your sense of the galaxy's history expanding, deepening. The Milky Way is not a structure that appeared fully formed. It is the result of billions of years of accumulation, collision, and evolution. It has been torn apart and reassembled. It has absorbed smaller galaxies, merged with them, incorporated their stars into its own structure. And the process is not over. The Milky Way is still accreting smaller satellite galaxies. The Magellanic Clouds, for example, are being slowly pulled apart by the Milky Way's gravity, and eventually they will be absorbed, their stars becoming part of our galaxy. The collision with Andromeda, billions of years in the future, will be the next major chapter in the Milky Way's formation history. The Milky Way's history is written in the ages and chemical compositions of its stars. Older stars, formed during the first phase, are found in the thick disk and the halo. They are metal poor, formed from gas that had been enriched by only a few generations of earlier stars. Younger stars, formed during the second phase, are found in the thin disk. They are metal-rich, formed from gas that has been cycled through many generations of stars, enriched by supernovae and stellar winds. Imagine the Milky Way not as a finished painting but as a living sculpture, constantly being reshaped. Stars are born in spiral arms, live for millions or billions of years, then die, returning their material to the interstellar medium where it will be incorporated into new stars. Small galaxies fall into the Milky Way, are torn apart, their stars scattered into new orbits. The galaxy grows, changes, evolves, never quite the same from 1 billion years to the next. Let that image settle gently over you. The myth that the Milky Way formed all at once belongs to a simplified view, a story that values neatness over complexity. The truth is messier, more violent, more interesting. The Milky Way is the product of a long, chaotic history, and that history is still being written. Your breathing is slow, and even now, your body deeply relaxed. The galaxy did not appear overnight, and neither did you. You are the product of billions of years of cosmic history, of stars that lived and died, of elements forged in their cores, of a long chain of events that stretches back to the beginning of the universe. You are part of the Milky Way's ongoing story, a brief chapter in a history that began 13 billion years ago and will continue for billions more. If sleep is near, you can welcome it. The myths can wait. For now, there is only this: the quiet rhythm of your breath, the weight of your body, and the knowledge that you are part of something ancient, something still evolving, something vast and patient and enduring. There is an old, persistent confusion about where the Sun is located within the Milky Way. Because the Sun is the center of our solar system, because everything we observe orbits around it, there is a subtle, almost unconscious assumption that the Sun must also be centrally located within the galaxy. This myth is rarely stated explicitly, but it lingers in the background, a leftover from earlier models of the universe when Earth, then the Sun, was believed to be at the center of everything. But the Sun is not at the center of the Milky Way. It is not even close. The Sun is located about 26,000 to 27,000 light-years from the galactic center, roughly halfway out from the center to the edge of the visible disk. We live in the suburbs of the galaxy, in a relatively quiet region between two spiral arms, far from the crowded, energetic center. This was not always known. In the early 1900s, astronomer William Herschel attempted to map the Milky Way by counting stars in different directions. He concluded that the Sun was near the center of a flattened distribution of stars. But this was an illusion created by interstellar dust, which blocks light from distant stars, making it seem like the distribution of stars was roughly equal in all directions. We appeared to be at the center because we simply could not see far enough to know otherwise. The true structure of the Milky Way and the Sun's position within it was revealed by Harlow Shapley in the 1910s and 1920s. Shapley studied globular clusters, large, spherical collections of old stars that orbit the galactic center. He noticed that these clusters were not evenly distributed across the sky. Instead, they were concentrated toward the constellation Sagittarius. This meant that the center of the galaxy was in that direction, not where the Sun was located. By measuring distances to these globular clusters using Cepheid variable stars, Shapley was able to estimate the size of the Milky Way and the Sun's position within it. He found that the Sun was located about 3/5 of the way out from the center, in one of the spiral arms. This was a profound shift in perspective, yet another step in the long process of humanity realizing that we are not at the center of things. As you listen to this, you may feel your sense of location shifting. You are not at the center. You are not even near it. You live on a planet orbiting a star in a quiet arm of a spiral galaxy, far from the crowded, energetic core. This is not a demotion. It is simply the truth, and in many ways, it is fortunate. The galactic center is a violent place. It is crowded with stars, dense clouds of gas and dust, and dominated by the supermassive black hole Sagittarius A star. Radiation levels are high. Stellar encounters are more frequent. The Sun's location, far from the center, is much calmer, much safer, a better place for stable planetary systems and the slow evolution of life. The Sun is also not exactly in the midplane of the galactic disk. Recent measurements show that the Sun is located about 55 light-years above the midplane, a small but measurable offset. This means that if you could see the Milky Way edge-on from a great distance, the Sun would appear slightly above the bright central band, not precisely in the middle. Imagine looking at the Milky Way from above, seeing it as a spiral galaxy with its bar and arms clearly visible. Find the center, the bright bulge dominated by the black hole. Now trace outward along one of the spiral arms, about halfway to the edge. There, in a relatively empty region between arms, is the Sun, a single yellow star among hundreds of billions, orbiting the galactic center at a speed of 220 kilometers per second, taking 225 million years to complete one full orbit. Let that image settle over you like a soft blanket. The myth that the Sun is at the center belongs to an older cosmology, a human-centered view of the universe. The truth is humbler. We live in the outskirts, in a quiet neighborhood, far from the crowded, dangerous center. This is not a lesser position. It is simply our position, and it has been good to us. Your breathing is slow and deep now, your body at rest in the knowledge that you are not at the center, and that is fine. The center is not always the best place to be. Sometimes the edge is safer, quieter, more conducive to the slow, patient work of living. If sleep is calling, you can answer. The myths can wait. For now, there is only this, the quiet truth of your location, neither central nor marginal, simply here, in a spiral arm of a vast galaxy, safe and held by the slow turning of stars. There is a common image of the Milky Way as a vast, empty expanse dotted sparsely with stars. In this picture, the galaxy is mostly void, with enormous distances between objects, with stars as rare islands in an ocean of darkness. This myth emphasizes the scale, the loneliness, the vast emptiness of space. And it is true that space is mostly empty, in the sense that the distances between objects are immense compared to the sizes of the objects themselves. But recent discoveries have revealed that the Milky Way is far more crowded than we once thought, not with stars necessarily, but with planets. For most of human history, we knew of only one planetary system, our own. The Sun and its 8 planets were the only confirmed example of planets orbiting a star. But in the 1990s, astronomers began detecting planets around other stars, and what started as a trickle became a flood. Today, we have confirmed the existence of thousands of exoplanets, and statistical analyses suggest that nearly every star in the Milky Way has at least one planet. Current estimates suggest that the Milky Way contains between 100 and 200 billion planets. Some estimates go even higher, suggesting that with 200 to 400 billion stars in the galaxy, and an average of more than one planet per star, the number of planets could be in the hundreds of billions or more. Among these, approximately 10 billion are thought to be Earth-like planets orbiting Sun-like stars in the habitable zone, the region where temperatures allow for liquid water on the surface. These are worlds where life, at least life as we know it, could potentially exist. As you listen to this, you may feel the galaxy becoming less empty, more populated. The Milky Way is not a sparse collection of isolated stars. It is a galaxy teeming with worlds, with planets of every size and type, orbiting stars of every kind. Rocky planets like Earth, gas giants like Jupiter, ice worlds, lava worlds, planets with thick atmospheres and planets with none, planets in tight orbits around red dwarfs and planets in wide orbits around massive stars. The discovery of exoplanets has been one of the most profound scientific achievements of the past few decades. Missions like NASA's Kepler identified thousands of candidate planets in just a small section of the galaxy, suggesting that planets are not rare anomalies but common features of stellar systems. Techniques like gravitational microlensing and the transit method have allowed astronomers to detect planets across a wide range of sizes and distances. The inner regions of the Milky Way, particularly around young, metal-rich stars, may host the largest number of habitable worlds. But habitable planets could exist throughout the galaxy, in the spiral arms, in the halo, perhaps even in globular clusters. The Milky Way is not just a collection of stars. It is a collection of planetary systems, each one potentially unique, each one a possible home for life. Imagine the Milky Way not as a sparse scattering of stars, but as a vast collection of solar systems. Hundreds of billions of planets, each one a world with its own geology, its own atmosphere, its own history. Some are barren, lifeless, too hot or too cold to support anything more complex than chemistry. But others might have oceans, continents, weather, ecosystems. Some might have developed life, simple or complex, microbial or intelligent. The galaxy is not empty. It is full of possibilities. Let that image settle gently over you. The myth of the mostly empty Milky Way belongs to a time when planets were thought to be rare, when Earth seemed like a unique anomaly. Now we know better. Planets are common, perhaps universal. The Milky Way is not a void. It is a galaxy of worlds. Your breathing is slow, and even now, your body deeply relaxed. You are not alone in the universe, not in the sense that there are other humans nearby, but in the sense that the galaxy is full of worlds, full of places where matter has organized itself into planets, where chemistry happens, where the conditions for complexity exist. The Milky Way is crowded with potential, with countless worlds waiting to be discovered. If sleep is near, you can welcome it. The myths can wait. For now, there is only this: the quiet truth that the galaxy is full, that planets are common, that Earth is one world among billions, held gently by the turning spiral of the Milky Way. When you look at images of the Milky Way, whether photographs taken from Earth or artistic renderings showing the galaxy from outside, you might notice that it appears predominantly white or pale, with perhaps some blue in the spiral arms and some yellow-orange near the center. There is a myth, subtle and persistent, that the Milky Way is simply white, a uniform, milky band of light, and that this whiteness is its defining characteristic. And in one sense, this is true. When astronomers measured the overall color of the Milky Way by comparing it to similar galaxies in the Sloan Digital Sky Survey, they found that the composite color is indeed white, specifically white as morning snow, with a color temperature of about 4,840 Kelvin, similar to a standard incandescent light bulb. To the human eye, this registers as white, neither warm nor cool, but neutral. But this overall whiteness conceals important variations. The Milky Way is not uniformly colored. Different regions have different colors, and those colors tell a story about the age, composition, and activity of the stars within them. The central bulge of the Milky Way is redder than average, dominated by older, cooler stars that formed billions of years ago. These red and orange stars have already burned through much of their fuel and are in the later stages of their lives. The center is a place of old stellar populations, where star formation has slowed dramatically, where the stars that remain are the long-lived survivors of earlier, more active times. The spiral arms, in contrast, are blur. They contain younger, hotter stars, massive blue giants that are burning their fuel rapidly and will die young in spectacular supernova explosions. These stars are found in regions of active star formation, where clouds of gas and dust are still collapsing to form new suns. The blue color of the spiral arms is a sign of youth, of energy, of ongoing stellar birth. As you listen to this, you may feel your understanding of the galaxy becoming more textured, more layered. The Milky Way is not a single uniform object. It is a complex structure with regions of different ages, different compositions, different levels of activity. The color variations are subtle, but they are real, and they reveal the galaxy's history. Interestingly, when compared to other spiral galaxies, the Milky Way is among the redder ones. This means that our galaxy is entering what astronomers call retirement, a phase where star formation is declining, where the galaxy is slowly aging, where fewer and fewer new stars are being born. The Milky Way is not a young, vigorous galaxy anymore. It is middle-aged, perhaps even approaching old age, still forming some stars but at a much slower rate than it did billions of years ago. This does not mean the Milky Way is dying. It simply means the galaxy has passed through its most active phase. The burst of star formation triggered by the merger with Gaia-Sausage Enceladus billions of years ago has long since ended. The thin disk continues to form stars, but at a steady, modest rate. The Milky Way is settling into a quieter phase, one that will last for billions of years more. The color of the galaxy also varies depending on where you look. Toward the galactic plane, where the disk is densest, the light is a mix of all stellar types, resulting in that overall white appearance. But out of the plane, in the halo, the light becomes redder, dominated by the old, metal-poor stars that formed in the earliest epochs of the galaxy's history. Imagine looking at the Milky Way from a great distance, seeing it as other galaxies see it. The center glows orange-red, a dense bulge of ancient stars. The spiral arms curve outward, traced by blue-white light, young stars marking the sites of recent formation. And throughout, scattered like dust, are the fainter red stars, the long-lived, patient ones, the stars that have been here since the beginning and will remain long after the blue giants have burned out. Let that image settle over you like a soft blanket. The myth that the Milky Way is purely white belongs to a simplified view, one that averages out the details. The truth is more complex. The galaxy is white overall, but that white is a mixture of red and blue, old and young, past and future. Your breathing is slow and deep now, your body deeply relaxed. The Milky Way is aging, like all things, moving through phases, changing over time. You, too, are part of that cycle, born from the material of old stars, composed of atoms forged in ancient cores, temporary but real, held gently by the turning galaxy. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet truth of color, the knowledge that even light carries history, and the sense of being held by a galaxy that is both old and still alive, both fading and still bright. There is a common image of the Milky Way as a perfect flat disk, like a dinner plate or a DVD, with stars arranged in a thin, orderly plane. This image appears in diagrams and models, always smooth, always level, always neatly structured. The myth suggests that the galaxy is a two-dimensional object, flat and stable, rotating like a wheel in the darkness. But the Milky Way is not flat. It is warped, twisted, bent out of shape by the gravitational influences of its neighbors and by the dynamics of its own rotation. Astronomers have known for decades that the outer parts of the Milky Way's disk are not aligned with the inner regions. The disk does not lie in a single plane but curves upward on one side and downward on the other, creating an S-shaped warp when viewed edge-on. This warping is most pronounced in the outermost regions of the disk, tens of thousands of light-years from the center, where the gravitational influence of the galaxy's massive inner regions is weaker. Recent research using data from Cepheid variable stars, bright, pulsating stars that can be seen across great distances, has revealed the full three-dimensional structure of the Milky Way's warp. These stars trace out the shape of the disk, and what they show is not a flat plane but a twisted, warped structure that resembles a bent record or a potato chip. The warp is thought to be caused by gravitational interactions with satellite galaxies, particularly the Magellanic Clouds. As these smaller galaxies orbit the Milky Way, their gravity tugs on the outer parts of the disk, bending it out of shape. The Milky Way's own dark matter halo may also play a role, with its asymmetric distribution contributing to the warping. As you listen to this, you may feel your mental image of the galaxy shifting, bending. The flat disk can curve, can take on depth and complexity. The Milky Way is not a rigid structure. It is flexible, dynamic, shaped by forces both internal and external. The warp is not unique to the Milky Way. Many spiral galaxies show similar distortions, especially in their outer regions. Warps are common in galaxies that have satellite companions or that are interacting with nearby galaxies. The Milky Way's warp is relatively modest compared to some other galaxies, but it is real and measurable. The discovery of the warp also helps astronomers understand the Milky Way structure in 3 dimensions. For a long time, because we are inside the galaxy, it was difficult to see its overall shape. We had to piece it together from observations of stars, gas, and dust, inferring the structure from their positions and motions. The warp was suspected but not clearly mapped until recent missions provided the precise data needed to trace the disk shape. Imagine the Milky Way not as a flat disk but as a slightly bent, S-shaped structure, like a vinyl record left too close to a heater. The inner regions remain relatively flat, held in place by the strong gravity of the central bulge and the supermassive black hole. But as you move outward, the disk begins to curve, bending upward on one side, downward on the other, creating a gentle, rolling warp that extends for tens of thousands of light years. Let that image settle gently over you. The myth of the flat Milky Way belongs to simplified models, to diagrams that prioritize clarity over accuracy. The real galaxy is more complex, more interesting, shaped by gravity and motion and the presence of other galaxies nearby. Your body is deeply relaxed now. You're breathing slow and steady. The Milky Way is not perfectly flat, and neither is anything else. All structures bend, warp, adapt to the forces acting on them. Flexibility is not a flaw. It is a response, a way of existing in a universe where nothing is ever truly isolated, where everything is shaped by its interactions with everything else. If sleep is calling, you can answer. The myths can wait. For now, there is only this: the quiet truth of the warped disk, the knowledge that even galaxies bend, and the sense of being held by a structure that is not rigid but flexible, not perfect but real. There is an implicit assumption, rarely stated but often believed, that the stars in the Milky Way are roughly the same age, that they formed around the same time when the galaxy came together, and that they have been here ever since. This myth treats the galaxy as a static population, a single generation of stars born in the distant past and slowly aging together. But the Milky Way contains stars of wildly different ages, from ancient stars that formed over 13 billion years ago, shortly after the Big Bang, to young stars still forming today in collapsing clouds of gas and dust. Recent research using data from ESA's Gaia mission has identified some of the oldest stars in the Milky Way, with ages ranging from 10 to 13 billion years. These stars are found primarily in the thick disk and the halo, and they are remnants from the galaxy's earliest phases of formation. They are metal poor, meaning they contain very few elements heavier than hydrogen and helium, because they formed from gas that had not yet been enriched by many generations of supernovae. These ancient stars are like archaeological artifacts, preserving information about the conditions in the early universe. By studying their compositions, motions, and distributions, astronomers can reconstruct the history of the Milky Way's formation, including dramatic events like the merger with the Gaia-Sausage-Enceladus galaxy about 10 billion years ago. But the Milky Way also contains very young stars, some only a few million years old. These stars are found in star-forming regions like the Orion Nebula, where clouds of gas and dust are actively collapsing under their own gravity, fragmenting into clumps that will become new stars. Star formation in the Milky Way continues today, though at a slower rate than in the past. As you listen to this, you may feel the galaxy becoming more dynamic, more alive. The Milky Way is not a museum of ancient stars. It is a living system, with multiple generations of stars coexisting, each generation formed from the ashes of earlier generations, each contributing to the ongoing chemical enrichment of the galaxy. The ages of stars can be determined through several methods. For some stars, like subgiants, stars that have finished burning hydrogen in their cores and are transitioning to the red giant phase, ages can be determined with great precision using data on their brightness and chemical composition. The Gaia mission's precise measurements of stellar brightness, combined with spectroscopic data from ground-based surveys, have allowed astronomers to determine the ages of hundreds of thousands of stars to within a few percent. By mapping the ages of stars throughout the galaxy, astronomers have discovered that different regions have different age distributions. The thick disk contains mostly old stars, formed during the galaxy's early, turbulent phase. The thin disk, where the Sun resides, contains a mix of old, middle-aged, and young stars, reflecting the ongoing star formation in this region. The halo is dominated by old, metal-poor stars, scattered into their current orbits by ancient mergers and interactions. Imagine the Milky Way as a city with buildings from every era. Some structures are ancient, crumbling, built when the city was first founded. Others are medieval, Renaissance, Victorian, each generation adding its own style, its own materials. And in the modern era, new construction continues, skyscrapers rising among the old neighborhoods. The city is not frozen in time. It is constantly evolving, with old and new coexisting, each contributing to the character of the whole. Let that image settle over you like a soft blanket. The myth that all stars are the same age belongs to a static view of the galaxy, one that does not account for the ongoing processes of birth and death, formation and destruction. The Milky Way contains stars from every epoch of cosmic history, from the first billion years after the Big Bang to stars being born right now, today, in clouds illuminated by the light of earlier generations. Your breathing is slow and deep now, your body at rest. You are not part of a single generation. You are part of a long chain, a continuum of life and death, birth and renewal. The atoms in your body were forged in stars of different ages, mixed together in the interstellar medium, incorporated into the cloud that became the solar system. You are made of stardust from multiple generations, old and young, all woven together into the temporary form of your body. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet truth of multiple generations, the knowledge that the galaxy is not static but dynamic, and the sense of being part of a story that stretches from the ancient past into the distant future. There is a subtle assumption that the name Milky Way is the natural, obvious name for our galaxy, that everyone who has ever looked up at that luminous band across the night sky has seen milk spilled across the darkness. This myth treats the Greek and Roman naming tradition as universal, as though the image of celestial milk is the only way to interpret that soft, diffuse glow. But the name Milky Way is specific to Western European tradition, derived from the ancient Greek galaxias kyklos, meaning milky circle, and the Latin via lactae, meaning Milky Way. The name comes from Greek mythology, specifically the story of Hera's breast milk spraying across the sky when she pulled away from the infant Heracles, who was nursing without her knowledge. The Roman poet Ovid wrote about the Milky Way in the Metamorphoses around AD 8, describing it as a high track seen when the sky is clear, called the Milky Way, and known for its brightness. The myth was later immortalized by Renaissance artist Jacopo Tintoretto in his painting The Origin of the Milky Way around 1575, cementing the association between the galaxy and spilled milk in Western imagination. But other cultures have seen different things in that same band of light. In many traditions, the Milky Way is not milk at all, but a path, a river, a seam in the fabric of the sky. Different cultures have created their own names, their own stories, their own ways of understanding the luminous river that cuts across the darkness. In some Native American traditions, the Milky Way is seen as the path of souls traveling to the afterlife. In Finnish mythology, it is called Linnanrata, the pathway of the birds, imagined as the route migratory birds take across the sky. In Chinese, it is known as the Silver River, Yin He, Inha, and in Japanese as the Managawa, Ten no Chon, meaning River of Heaven. As you listen to this, you may feel your perspective widening, opening to include other ways of seeing. The Milky Way is not inherently milky. It is luminous, yes, but its meaning is shaped by the culture observing it, by the stories people tell, by the metaphors they use to make sense of the cosmos. In Arabic traditions, the galaxy is sometimes called Na al-Sama, meaning river of the sky. In Armenian, it is Hardagoga Janapa, meaning straw thief's way, referring to a story about a thief who stole straw and scattered it across the sky while fleeing. In Turkish, one traditional name is Samanyolu, also meaning strawway or hay road. The diversity of names reveals something important. Humans across cultures have always looked up at the Milky Way and tried to make sense of it, to integrate it into their understanding of the world. The band of light was too prominent, too mysterious to ignore, but the meanings they assigned to it varied widely, shaped by local mythology, by the natural world they inhabited, by the stories that mattered to them. The Greek name happened to become dominant in Western science and eventually spread globally through the influence of European astronomy. But this dominance is historical, not inevitable. The Milky Way could just as easily have been known universally as the Silver River, the path of birds, the river of heaven. The choice of Milky Way as the standard astronomical term is a product of specific cultural and historical circumstances, not an inherent truth about the galaxy itself. Imagine standing in different places on Earth, in different times, listening to people describe the band of light overhead. In ancient Greece, you hear galaxias, milk. In China, you hear Einha, silver river. In Finland, Linnanrata, bird's path. In Armenia, the straw thief's way. Each name carries a story, a way of seeing, a cultural understanding. None of them is wrong. All of them are attempts to capture something vast and luminous in human language. Let that image settle gently over you. The myth that Milky Way is the universal, natural name belongs to a limited perspective, one that assumes Western European culture speaks for all humanity. The truth is richer. The galaxy has many names, many stories, many ways of being understood. The Milky Way is what we call it in English, but it is not the only name, and perhaps not even the most beautiful one. Your breathing is slow, and even now, your body deeply relaxed. The galaxy does not care what we call it. It turns through space regardless of our names, our stories, our attempts to capture it in language. But the diversity of names reminds us that humans everywhere have looked up, have wondered, have tried to understand their place in the cosmos. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet truth that the galaxy has many names, that each culture brings its own vision, and that you are held by something too vast to be captured in any single word, any single story. There is an assumption that because we live inside the Milky Way, we should be able to see all of it, that our position within the galaxy gives us a privileged, comprehensive view of its structure. This myth suggests that mapping the Milky Way should be straightforward. Just look around, observe the stars, and piece together the shape. But we cannot see the entire Milky Way. In fact, we cannot see most of it. Our view is severely limited by interstellar dust, vast clouds of tiny particles that fill the galactic plane and block visible light from distant stars. Mapping the Milky Way from inside has been compared to trying to map an entire forest while being tied to a single tree in the middle of it. You can see the trees immediately around you, but the distant parts of the forest are obscured by the very trees you're trying to map. The Milky Way's disk is filled with dust lanes, particularly along the spiral arms, where star formation is most active. These dust clouds are opaque to visible light, creating dark patches in the night sky that are not voids but barriers, regions where light cannot reach us. The dust is most concentrated near the galactic plane, which is exactly where most of the stars, gas, and interesting structure are located. This means that when we look toward the center of the galaxy, toward Sagittarius, we can only see a few thousand light-years through the disk before the dust becomes too thick. The central regions of the galaxy, tens of thousands of light-years away, are completely invisible in optical light. This is why, for much of the 20th century, astronomers had only a vague understanding of the Milky Way structure. They knew it was a spiral galaxy, but the number of spiral arms, their exact shapes, and the details of the bar were all uncertain. The dust made it impossible to see clearly. As you listen to this, you may feel a sense of the challenge astronomers face. Imagine trying to understand the shape of something you're inside, something so large that light takes 100,000 years to cross it, and most of your view is blocked by clouds of dust. The Milky Way is not transparent. It is opaque, secretive, reluctant to reveal its full structure to observers trapped within it. The solution has been to use infrared and radio telescopes, which can penetrate the dust. Infrared light, with its longer wavelengths, passes through dust clouds more easily than visible light. Radio waves pass through even more easily. Missions like NASA's WISE, Wide Field Infrared Survey Explorer, and Spitzer Space Telescope have mapped the galaxy in infrared, revealing structures that are invisible to optical telescopes. WISE, in particular, has been valuable for discovering embedded star clusters, young stars still shrouded in the dust clouds where they formed. These clusters trace out the spiral arms, revealing the galaxy's structure even where visible light cannot penetrate. By identifying over 400 of these dust-shrouded nurseries, WISE has helped astronomers map the Milky Way spiral arms more accurately than ever before. Radio telescopes observe emissions from hydrogen gas, which fills the galaxy and is concentrated in the spiral arms. By measuring the Doppler shifts of this hydrogen emission, astronomers can determine the gas's velocity and distance, building up a three-dimensional map of the galaxy's structure. This technique has revealed features like the warp in the outer disk and the detailed structure of the spiral arms. Even with these advanced techniques, mapping the Milky Way remains challenging. The region inside the Sun's orbit is particularly difficult because the mathematical solutions for converting observations into positions become ambiguous. There's no way to tell exactly where the gas is located, so this inner region often appears as a hole in maps of the galaxy. Imagine the Milky Way not as a transparent structure but as a fog-filled landscape. You can see clearly for a few kilometers in any direction, but beyond that, the fog thickens and the distant regions become vague, uncertain, inferred rather than observed. You know there are mountains in the distance because you can see their tops poking through the fog, but their shapes, their exact locations, their connections to each other, all of this must be pieced together from partial information. Let that image settle over you like a soft blanket. The myth that we can see the entire Milky Way belongs to a view that doesn't account for dust, for the opacity of the interstellar medium. We are not outside observers with a clear view. We are embedded inside, looking through layers of obscuring material, piecing together the structure from whatever glimpses we can get. Your breathing is slow and deep now, your body at rest. You do not need to see everything to know it exists. The Milky Way surrounds you, even the parts you cannot see, even the regions hidden behind dust and distance. You are held by the galaxy structure whether you can map it or not, safe within its turning arms. If sleep is calling, you can answer. The myths can wait. For now, there is only this, the quiet truth that much of the galaxy is hidden, that maps are incomplete, and that you are held by something vast even when you cannot see all of it. Chapter 15. The name Milky Way is universal. When language reveals culture. There is a subtle assumption that the name Milky Way is the natural, obvious name for our galaxy, that everyone who has ever looked up at that luminous band across the night sky has seen milk spilled across the darkness. This myth treats the Greek and Roman naming tradition as universal, as though the image of celestial milk is the only way to interpret that soft, diffuse glow. But the name Milky Way is specific to Western European tradition, derived from the ancient Greek galaxias kyklos, meaning milky circle, and the Latin via lactae, meaning Milky Way. The name comes from Greek mythology, specifically the story of Hera's breast milk spraying across the sky when she pulled away from the infant Heracles, who was nursing without her knowledge. The Roman poet Ovid wrote about the Milky Way in the Metamorphoses around AD 8, describing it as a high track seen when the sky is clear, called the Milky Way, and known for its brightness. The myth was later immortalized by Renaissance artist Jacopo Tintoretto in his painting The Origin of the Milky Way around 1575, cementing the association between the galaxy and spilled milk in Western imagination. But other cultures have seen different things in that same band of light. In many traditions, the Milky Way is not milk at all, but a path, a river, a seam in the fabric of the sky. Different cultures have created their own names, their own stories, their own ways of understanding the luminous river that cuts across the darkness. In some Native American traditions, the Milky Way is seen as the path of souls traveling to the afterlife. In Finnish mythology, it is called Linnanrata, the pathway of the birds, imagined as the route migratory birds take across the sky. In Chinese, it is known as the Silver River, Yin He, Inha, and in Japanese as the Managawa, Ten no Chon, meaning River of Heaven. As you listen to this, you may feel your perspective widening, opening to include other ways of seeing. The Milky Way is not inherently milky. It is luminous, yes, but its meaning is shaped by the culture observing it, by the stories people tell, by the metaphors they use to make sense of the cosmos. In Arabic traditions, the galaxy is sometimes called Na al-Sama, meaning river of the sky. In Armenian, it is Hadagoga Janapa, meaning straw thief's way, referring to a story about a thief who stole straw and scattered it across the sky while fleeing. In Turkish, one traditional name is Samanyolu, also meaning strawway or hay road. The diversity of names reveals something important. Humans across cultures have always looked up at the Milky Way and tried to make sense of it, to integrate it into their understanding of the world. The band of light was too prominent, too mysterious to ignore. but the meanings they assigned to it varied widely, shaped by local mythology, by the natural world they inhabited, by the stories that mattered to them. The Greek name happened to become dominant in Western science and eventually spread globally through the influence of European astronomy. But this dominance is historical, not inevitable. The Milky Way could just as easily have been known universally as the Silver River, the Path of Birds, the River of Heaven. The choice of Milky Way as the standard astronomical term is a product of specific cultural and historical circumstances, not an inherent truth about the galaxy itself. Imagine standing in different places on Earth, in different times, listening to people describe the band of light overhead. In ancient Greece, you hear galaxias, milk. In China, you hear Einha, Silver River. In Finland, Linnanrata, Bird's Path. In Armenia, the Straw Thief's Way. Each name carries a story, a way of seeing, a cultural understanding. None of them is wrong. All of them are attempts to capture something vast and luminous in human language. Let that image settle gently over you. The myth that Milky Way is the universal, natural name belongs to a limited perspective, one that assumes Western European culture speaks for all humanity. The truth is richer. The galaxy has many names, many stories, many ways of being understood. The Milky Way is what we call it in English, but it is not the only name, and perhaps not even the most beautiful one. Your breathing is slow, and even now, your body deeply relaxed. The galaxy does not care what we call it. It turns through space regardless of our names, our stories, our attempts to capture it in language. But the diversity of names reminds us that humans everywhere have looked up, have wondered, have tried to understand their place in the cosmos. If sleep is near, you can welcome it. The myths can wait. For now, there is only this, the quiet truth that the galaxy has many names, that each culture brings its own vision, and that you are held by something too vast to be captured in any single word, any single story. Chapter 16, we can see the entire Milky Way when dust blocks the view. There is an assumption that because we live inside the Milky Way, we should be able to see all of it, that our position within the galaxy gives us a privileged, comprehensive view of its structure. This myth suggests that mapping the Milky Way should be straightforward. Just look around, observe the stars, and piece together the shape. But we cannot see the entire Milky Way. In fact, we cannot see most of it. Our view is severely limited by interstellar dust, vast clouds of tiny particles that fill the galactic plane and block visible light from distant stars. Mapping the Milky Way from inside has been compared to trying to map an entire forest while being tied to a single tree in the middle of it. You can see the trees immediately around you, but the distant parts of the forest are obscured by the very trees you're trying to map. The Milky Way's disk is filled with dust lanes, particularly along the spiral arms, where star formation is most active. These dust clouds are opaque to visible light, creating dark patches in the night sky that are not voids but barriers, regions where light cannot reach us. The dust is most concentrated near the galactic plane, which is exactly where most of the stars, gas, and interesting structure are located. This means that when we look toward the center of the galaxy, toward Sagittarius, we can only see a few thousand light years through the disk before the dust becomes too thick. The central regions of the galaxy, tens of thousands of light years away, are completely invisible in optical light. This is why, for much of the 20th century, astronomers had only a vague understanding of the Milky Way structure. They knew it was a spiral galaxy, but the number of spiral arms, their exact shapes, and the details of the bar were all uncertain. The dust made it impossible to see clearly. As you listen to this, you may feel a sense of the challenge astronomers face. Imagine trying to understand the shape of something you're inside, something so large that light takes 100,000 years to cross it, and most of your view is blocked by clouds of dust. The Milky Way is not transparent. It is opaque, secretive, reluctant to reveal its full structure to observers trapped within it. The solution has been to use infrared and radio telescopes, which can penetrate the dust. Infrared light, with its longer wavelengths, passes through dust clouds more easily than visible light. Radio waves pass through even more easily. Missions like NASA's WISE, Wide Field Infrared Survey Explorer, and Spitzer Space Telescope have mapped the galaxy in infrared, revealing structures that are invisible to optical telescopes. WISE, in particular, has been valuable for discovering embedded star clusters, young stars still shrouded in the dust clouds where they formed. These clusters trace out the spiral arms, revealing the galaxy's structure even where visible light cannot penetrate. By identifying over 400 of these dust-shrouded nurseries, WISE has helped astronomers map the Milky Way spiral arms more accurately than ever before. Radio telescopes observe emissions from hydrogen gas, which fills the galaxy and is concentrated in the spiral arms. By measuring the Doppler shifts of this hydrogen emission, astronomers can determine the gas's velocity and distance, building up a three-dimensional map of the galaxy's structure. This technique has revealed features like the warp in the outer disk and the detailed structure of the spiral arms. Even with these advanced techniques, mapping the Milky Way remains challenging. The region inside the Sun's orbit is particularly difficult because the mathematical solutions for converting observations into positions become ambiguous. There's no way to tell exactly where the gas is located, so this inner region often appears as a hole in maps of the galaxy. Imagine the Milky Way not as a transparent structure but as a fog-filled landscape. You can see clearly for a few kilometers in any direction, but beyond that, the fog thickens and the distant regions become vague, uncertain, inferred rather than observed. You know there are mountains in the distance because you can see their tops poking through the fog, but their shapes, their exact locations, their connections to each other, all of this must be pieced together from partial information. Let that image settle over you like a soft blanket. The myth that we can see the entire Milky Way belongs to a view that doesn't account for dust, for the opacity of the interstellar medium. We are not outside observers with a clear view. We are embedded inside, looking through layers of obscuring material, piecing together the structure from whatever glimpses we can get. Your breathing is slow and deep now, your body at rest. You do not need to see everything to know it exists. The Milky Way surrounds you, even the parts you cannot see, even the regions hidden behind dust and distance. You are held by the galaxy's structure whether you can map it or not, safe within its turning arms. If sleep is calling, you can answer. The myths can wait. For now, there is only this, the quiet truth that much of the galaxy is hidden, that maps are incomplete, and that you are held by something vast even when you cannot see all of it. Chapter 17, The Quiet Truth. You are part of the turning spiral, final chapter. And so we come to the end of this long, gentle journey through myths about the Milky Way. You have drifted through misconceptions about the galaxy's size, its structure, its motion, its history. You have seen how assumptions fade when held up to careful observation, how the galaxy is more complex, more dynamic, more mysterious than any simple story can capture. The Milky Way is not the universe, but it is your home. It is not a perfect spiral, but a barred, warped structure shaped by billions of years of evolution. It is not stationary, but moving through space at incredible speeds, carrying you with it. It is not made mostly of stars, but of invisible dark matter that holds everything together. It did not form all at once, but through a violent, chaotic history of mergers and collisions. It is not flat, but warped by the gravity of its neighbors. It does not contain stars of a single age, but generations spanning from the ancient past to the present moment. The Milky Way is not empty, but filled with hundreds of billions of planets, many of them potentially habitable. It is not purely white, but a mix of colors that reveal the ages and types of stars within it. It cannot be seen entirely from our position inside it, obscured as we are by dust and distance. And it has many names, each reflecting the culture that observed it, the stories people told to make sense of that luminous band across the night sky. Tonight, as you rest here in the darkness, you are invited to hold the real Milky Way in your mind, not the simplified myths, but the complex, beautiful, ever-changing structure that actually exists. A barred spiral galaxy about 100,000 light-years across, containing 200 to 400 billion stars, embedded in a vast halo of dark matter, slowly rotating, slowly colliding with smaller galaxies, slowly moving toward an eventual merger with Andromeda billions of years in the future. You are part of this galaxy. Every atom in your body was forged in the core of a star, perhaps multiple stars from multiple generations. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stars that lived and died within the Milky Way, that exploded and scattered their material into the interstellar medium, where it was eventually incorporated into the cloud that became the solar system, the Earth, and you. You are made of the galaxy. You are not separate from it, not a passive observer looking at something distant and alien. You are the Milky Way looking at itself, consciousness arising from matter that was forged in stellar cores, arranged into the temporary form of a human being, capable for a brief moment of looking up at the night sky and understanding what it sees. As you drift deeper into rest, let the myths fall away one by one. The Milky Way is not what the simple story said it was. It is more complex, more beautiful, more mysterious. It is older than you can fully comprehend, larger than you can hold in your imagination, more dynamic than any static image can capture. But it is also your home, the only galaxy you will ever know from the inside, the structure that holds the sun, the earth, and everything you have ever loved. Imagine yourself floating above the galactic plane, looking down at the Milky Way from a great distance. You see the bright central bulge, dominated by old stars and the supermassive black hole. You see the bar cutting through the center, funneling gas and dust toward the core. You see the spiral arms curving outward, traced by young blue stars and glowing nebulae where new stars are being born. You see the warp in the outer disk, the gentle S-curve created by the gravity of satellite galaxies. And somewhere in one of those spiral arms, about halfway out from the center, you see a single yellow star, unremarkable among hundreds of billions. That is the Sun. And orbiting that Sun is a small blue planet where you are lying right now, breathing softly, resting, preparing to sleep. The scale is so vast that you cannot even see the Earth from this perspective, but you know it is there, and you know you are on it, part of the turning spiral, part of the ancient pattern. Let that image settle over you like the softest blanket. You are not lost in the vastness. You are held by it. The Milky Way is not an empty void, but a structure, a system, a home. You are connected to it through gravity, through chemistry, through the long history of stellar evolution that produced the elements of your body. You are the galaxy experiencing itself, a temporary arrangement of atoms capable of wonder. Your breathing is slow and deep now, effortless, automatic. The day has faded completely, and the night has opened up around you. You do not need to understand everything about the Milky Way to rest safely within it. You do not need to see its full structure to trust that it is there, turning slowly through the darkness, carrying you with it on a journey that began billions of years ago and will continue long after you are gone. The myths told you the galaxy was simpler than it is, smaller, more static, more comprehensible. But the truth is better. The Milky Way is vast, ancient, complex, and you are part of it. Not separate, not alone, not insignificant, but woven into the fabric of the galaxy, made of its matter, shaped by its history, held by its gravity. If thoughts arise, let them drift past like clouds across a dark sky. They do not need to be solved, do not need to be answered. The galaxy does not ask you to understand everything. It only asks you to exist, to breathe, to be part of the pattern for as long as you can. And tonight, you are doing exactly that. You are existing, breathing, resting, held gently by the Earth, which is held by the Sun, which is held by the Milky Way, nested circles of existence, each holding the other. So let yourself go now. Let the night carry you. Let sleep come, not as an escape, but as a return, a homecoming to the quiet place where you are simply yourself, part of the turning spiral, part of the ancient pattern, safe within the arms of the Milky Way. The myths have been examined, set aside, replaced with something more true, more beautiful, more vast. And you are allowed to rest in that truth, to let it hold you, to trust that you are exactly where you belong. Thank you for spending this time here, for drifting through the myths, for allowing yourself to see the Milky Way a little more clearly. May your dreams tonight be filled with starlight, with the quiet knowledge that you are made of the same matter as the galaxy, that you are part of something ancient and ongoing, something that will continue turning long after this night has passed. You do not need to be anything more than what you are. You are stardust, temporarily conscious, resting in the arms of the galaxy that made you. Good night. Sleep well. The Milky Way holds you gently as you rest.